everyone, welcome to the next topic, which is topic B, measurements. Well, we measure a lot here in AP Chemistry or in any chem class, so we want to make sure we know what we're doing with those measurements. So this is the first video in that series, and we're dealing with scientific notation. So I know you've dealt with scientific notation before, but I just want to give you a crash course or a refresher for it. So talk about why we use scientific notation and the difference between the negative and positive exponents. So in scientific notation, we actually simplify very long numbers. So it helps us figuring out pretty much what the numbers are, or excuse me, what important numbers that there are. So a quick example here, we have 280,000 times 10.0. So we need to know what ends up forming as a result. So we end up having a really long number. In scientific notation, we end up simplifying that number. So we use exponents to help us figure that out. So negative exponents mean that the number is going to be less than 1, and positive exponents mean that the number is going to be greater than 1. So here's a quick example. We have 2.43 times 10 to the negative 3. So I'm going to rewrite that number, and again, I apologize for my stylus. It's a negative number, so we want to make sure we have a small digit. It's going to be less than 1. So let's make sense of it. If we move the decimal place to the right, we'd end up having a number that's greater than 1. We want to have something that's less than 1, though. So we move the decimal place over 3 spots. So 1, there we go, 1, 2, 3. All right, so you guys know what you can get me for a birthday present, right? A new stylus. Okay, so we have 243 is our expanded number. And this is, again, why I have you guys listen to my videos as opposed to just taking screenshots, because sometimes they don't always show up how we want them to. So anyway, so if we were going to expand the number, this is what it would look like, 0.00243. The second example here is going to be a really teeny tiny number, but we want to make sure that we put it in scientific notation. So our decimal point needs to land between the first and second non-zero digit. So pretty much the first non-zero digit here is 9 and the second one is 7. So we're going to move the decimal place over till it lands between those two. Alright, so let's try this. So we have 1, 2, 3, 4. So we have 9.740. Come on. And let's get that decimal place in there. Times 10 to the negative 4th. Again, that negative number means it's going to be a really teeny tiny number, less than 1, and that makes sense here. We're going to have a really small number. The next one are dealing with positive, whoopsies. So positive exponents are, I think, greater than 1. So we have 9.74 times 10 to the 4th. So we're going to move that decimal place over to the right 4 spots. So 1, 2, 3, 4. So we have 974. And then, let's see, we have 2 more placeholders. So our number is 97,400. To make 7,310 into scientific notation, we know that the decimal point is right here, so we're going to go 1, 2, 3. We're going to land between the first and second digit. So 7.310. Keep that 1 in there as well, or excuse me, keep that 0 in there. Alright, this may not work, darlings. Sorry. Okay, times, so we move the decimal place over 1, 2, 3, so times 10 to the 3rd power. So that's going to be your positive exponent. So a quick little summary. Use a negative exponent if the number is smaller than 1. Use a positive exponent if the number is larger than 1. Have a good day.